Well, it's only been a few days, but I already got the part in. I looked around all over the internet, and the going rate for this this part is about 20 bucks, and so I had a few different sources I could get it from. I mean, I've seen it as expensive as $40 or $36, I think was the highest. Cheapest I saw it was like $18, but then when you added in the shipping charges, it went up. So I ended up going with Amazon only because I think the part was like $19 or $20, and then of course there would have been shipping, but if you go over $25 you get free shipping. So rather than pay those charges and shipping charges, I just added something onto the order to bring it up to over 25. And in this case I decided I was looking at some books, and I saw this book on metal lathe for home machinists, and it looked interesting. It's got a bunch of projects in here for first timers, and that'll come in. I think that'll come in handy for when I get the lathe home. So we'll go install this, test it out. Oh, UPS was just here, and he just dropped off the next project for the trailer. Steady fast system. More on that later. Alright, so I just reinstalled the new part, and a 3/8 inch nut driver makes quick work of that because it's kind of too difficult to get a wrench in there, really. Now I just need to attach my two slip-on connectors here. Okay, and now I can reinstall my cover. Alright, now I'm going to install the small cover that goes over the back of the heating element. Now it's time to reinstall the burner assembly, which is the burner tube and the whole solenoid and regulator. The thing I wanted to mention too is this thing down here, you see that's all rusted. Looks like a threaded pipe plug. This is actually what's called a sacrificial anode. On the back side of this plug there's a rod, and it's specially designed. It's actually designed to corrode, and what it does is by corroding it actually gives up itself, and it stops, I think it's called what they call a galvanic reaction. Basically there's a process that causes rust, and this is actually saving your tank from corroding by having this here. So this should be replaced typically, I think, if I recall correctly, once a season. So I'm not doing that at this time, but if cheap enough device, I'll probably replace it next spring. Oh, one last note about this. This is also a great place to open up your heater tank and drain your tank when you're winterizing. So when I open this up to drain the tank, I'll also be able to take a good look at the condition of the rod. Okay, so I've got the burner reinstalled, which is basically I have to make sure I reattached these two quick electrical connectors, and then down here this stud goes down into a slot in this bracket, and this nut gets installed. And then over here you've got, behind this assembly, you've got 4 sheet metal screws that hold this bracket in place. And then of course you've got the gas line where it comes in right here, which I've got to tighten that up. It's important to note you never want to use any thread sealant or Teflon tape on these threads. This is a compression fitting. Where the actual seal is taking place is where the flared end of that fitting or pipe engages this cone-shaped end of this fitting. So the purpose of the threads is just to pull those two mating surfaces that are deep inside there together. The threads do not actually do anything as far as the actual sealing of the gas. Let me try and clarify. In other words, if you have a leak where you've got gas coming out past these threads here, then your problem has nothing to do with the threads needing to be sealed. It has to do with the fact that those two mating surfaces aren't sealing. Alright, now I'm going to turn the gas supply back on. Alright, now I'm going to turn the gas supply back on. Now it's important that I check for leaks here at this fitting, and the way I do that is I take a couple of drops of dishwashing detergent, put it in a container, add some water, get a nice soapy, sudsy solution on there, and then just spread some of it on this area here and look for bubbles. And since it's not blowing any bubbles, we can safely say that we do not have a leak there. Now I've gone and hooked up my water supply, and what I want to do is I want to run the hot water faucet so I can purge any air out of the tank that might be in there before I attempt to run it. So we get this handy faucet right here inside this equipment compartment here. Because they get a lot of air in the system, and we don't want that air in the tank when we fire the element. So you see a lot of bubbles in the filter there, and of course the erratic flow. Alright, got most of the air out of the system. You can hear now it's a steady stream and it's really not spitting anymore. So now I come back to the circuit breaker panel, put on the main power to the heater, and put on the switch. Now wait. I don't know if you can hear that or not, but within 30 seconds you can hear it starting to sizzle. That's somewhere between like a 1,000 and 1,400 watt element, so it's only a 6-gallon tank, so it should work fairly quickly. So if everything's operating correctly, what's going to happen is it's going to continue to heat the water until the temperature at that new device that I put in reaches the set point of that lower thermostat cutout, which I think is 130 degrees. And at that point the cutout should open, and that cutout will cycle on and off to maintain a 130 degree water temperature. Alright, it's been about 10 or 15 minutes. I just came back over here and I still hear some sizzling, which is a good sign. So now we'll check for hot water. Not hot yet. I'd be concerned normally, but because I could still hear sound. Actually, now it seems like that stopped. Well, it took a while, but I now have hot water. So, one last test to do. Now that I know the electric heater is working, I'm going to switch it back off, and I'm going to fire up the gas heater just to make sure that's still working correctly, since I had that all apart. Alright, so for the final test, we're just going to light the hot water heater on gas, and I've already shut the electricity off to the heater, the 110 to the heater. And here's my switch, and this is a direct source ignition type water heater, so when I turn the switch on, this little LED will light, and there'll be the auto spark mechanism will kick in, and once the pilot is lit and established, this light will go out. Might take me a couple of tries of cycling because I did have that gas line disconnected, and so now there's going to be some air in that line. Actually, sounds like it lit on the first try. And there we go. Our heater's lit. Alright, so now I'm going to shut it off, and we're ready to go camping.